Hi class, this is Marissa and I will be presenting the drug Urispas. The brand name of Urispas is obviously Urispas. The generic name is Flavoxate hydrochloride. Urispas is a muscle relaxant focusing on smooth muscles such as the bladder, GI tract, respiratory tract, and genitals. If no one knows what a muscle relaxant is, it's defined as a drug whose purpose is to encourage relaxation in parts of the body or muscles. And Urispas is used to treat urinary tract or bladder issues by relaxing the muscles in the bladder. It prevents it from unconsciously leaking urine, any overactive bladder symptoms, or pain in the bladder. An overactive bladder is a feeling in the bladder when one feels the constant urge to urinate, even when they just went or the bladder is empty. Urispas contains an antispasmodic, which will relax the muscles inside of the urinary tract and remove any pain. An antispasmodic is a drug that relieves spasm and cramps in the bladder, stomach, and intestines. And one interesting thing about Urispas is it's the first drug in the antispasmodic agents class of drugs to be approved by the FDA in 1970. Next up is contraindications of Urispas. They are as follows. Do not use if you're 12 years of age or younger, if you're pregnant or breastfeeding, if you have pyloric or a duodenal obstruction. To define those two things, pyloric or duodenal obstruction, also known as a gastric outlet obstruction, is when the muscles of the pylorus or duodenum narrow, and then it blocks any waste from exiting the stomach into the small intestine. Do not use if you have intestinal lesions, which are when the intestines have suffered damage from any injuries or diseases. Do not use if you have achalasia. Achalasia is a very rare disorder where the muscles of the esophagus don't contract, which is also known as peristalsis, which is when your esophagus pushes your food down into your stomach. Lastly, if you have any GI hemorrhages, which are also known as gastrointestinal hemorrhages. Next up, we have the drugs that Urispas interacts with. It's known to interact with 322 different types of medication, according to drugs.com. However, the most common interactions are with S-ketamine, ketamine, potassium chloride, propoxyphene, potassium citrate, sodium oxybate, and topiramate. And then the side effects are as follows, the most severe being coma or death. Now to the fun part. Unfortunately, I did have to speed it up a little bit, but as you can see, I'm just drawing my molecule. Ends and bends are carbons, like we know. Here's a few carbon chains with a few double bonds. We've got 4 oxygens in here, another carbon chain, and then hydrogen chloride in the corner there. This is always the fun part for me. I like figuring out how many hydrogens I need for each carbon, but as you can see, these carbons only need 2 hydrogens. Over here, these only need 1 because they have double bonds. These also only need 1 because they have a double and a single bond. Now we're moving on to the Vesper theory of molecular geometry. First, I will highlight all of the tetrahedrals, the central atoms being carbon, because they have 4 electron regions around it. Next is trigonal planar. I have way more of these than I do tetrahedral. All of these have 3 electron regions surrounding the central atom. All of them actually are carbons. And next, I will be working on trigonal pyramidal. The shape is like a pyramid with the 3 bonds kind of on the bottom and then the 2 lone pairs on top. or the 1 lone pair, sorry. And then this is bent 109 point. Next, I'm working on the molecular formula and molar mass calculation, doing the calculations on the calculator for you so that you can see. This is the molecular formula of my drug, C26H25 NO4Cl. In the calculation, the first number, so the first number would be 12.001, is the molar mass of carbon, and 1.008 is the molar mass of hydrogen. 14.007 is the molar mass of 1 nitrogen. 15.999 is the molar mass of oxygen. And 35.45 is the molar mass of chlorine. And then I'm multiplying it by how many of the atoms there are. So 12.001 times 26, because there's 26 carbons. 1.008 times 25, because there are 25 hydrogens. 14.001 alone, because there's just 1 nitrogen, and so on. You get the idea. Add them all together, and my final answer was 450.679 grams of flavoxate hydrochloride, also known as Urispas. Now we'll work on the exercise that was given to us in the lab manual. I'm not sure what molecule this is, but we are just drawing water molecules around the drug, and then we'll see who's accepting and who's donating hydrogen bonds. So the first one, I'm going to draw, I'm doing it really quickly. All of these H's bonding with any O's, F, or N's, those are donors. And then the O's, F, or N's are acceptors because they're accepting the hydrogen. All right, now we will work on hydrogen bonding with water with my drug, Urispas. So I'm just drawing hydrogens around my molecule. I've got a few. Now we're going in with the bonding. So this H will bond with nitrogen. This hydrogen will bond with oxygen again, and hydrogen with oxygen again, and one more time. So the hydrogens are donating to the nitrogen and the oxygens, making the nitrogens and the oxygens acceptors because they are accepting the hydrogens in the water molecules. Here I'm highlighting all polar bonds. The oxygen, nitrogen, and chlorine are most electronegative compared to the carbon and hydrogen bonds. The carbon and hydrogen bonds are nonpolar, and there are more of those than there are polar bonds. Because of this, I predicted that my molecule is borderline polar. Since water is a polar bond, I predicted that Urispas is not soluble in water. When researching whether or not this was true, I couldn't find any information on solubility on any reputable websites such as Merck Index, PDR, or PubChem. However, I did find something from drugfuture.com, not sure how reputable that website is, stating that Urispas is only slightly soluble in water, which makes sense with how many polar bonds there are in Urispas, not a lot. Now for solution calculations. First, I had to convert 50.0 milliliters to liters by dividing 50.0 milliliters by 1,000, getting 0.500 liters, maintaining 3 sig figs. I got my answer to be 0.00115 moles of Urispas by multiplying 2.30 times 10 to the negative second power by 0.0500 liters. Now, in order to convert moles to grams, I used conversion units. Since the molar mass of Urispas is 450.679 grams, I multiplied that by 0.00115 moles of Urispas to get my final answer of 0.518 grams of Urispas. Lastly, in order to find the weight by volume, I used the mass by volume percentage equation and plugged in my numbers. I got the mass solute to be 0.060 grams of Urispas, and then in order to convert to milligrams, I multiplied that by 1,000 milligrams, since there's 1,000 milligrams in 1 gram, making my final answer to be 60 milligrams of Urispas. Thank you for watching.